First, Industrial Revolution. Late 18th century, early 19th century. Historical background. The first Industrial Revolution was an economic and technological transformation that began in Britain in the late 18th century and spread worldwide. At the time, European society was based on a traditional agrarian system. However, increasing population, the growth of commercial capitalism, and the expansion of colonial trade necessitated new modes of production. Britain was particularly well positioned with abundant coal and iron resources, a stable political system, entrepreneurial spirit, and land privatization. Core technology: steam engine. The most iconic technological innovation was the steam engine, improved by James Watt. This invention used coal as fuel to generate continuous and powerful energy, enabling its application across a wide range of industrial machinery. Characteristics: beginning of mechanization. Production based on manual labor was replaced with machine-based industrial manufacturing. The textile industry exemplified this shift with inventions like the spinning jenny and power loom, which dramatically increased productivity. In transportation, steam locomotives and steamships revolutionized logistics. Socioeconomic impact. Surge in productivity. More goods could be produced in the same amount of time, leading to price reductions and increased consumption. Urbanization: factories were built in urban centers, drawing rural populations into cities and creating an urban working class. Rise of industrial capitalism. A clear division between capitalists and laborers emerged, and the accumulation of capital led to rapid industrial expansion. Labor issues and social reform issues like child labor, long working hours, and low wages gave rise to labor movements and the push for social reform. Second, Industrial Revolution. Late 19th century, early 20th century. Historical background. The Second Industrial Revolution was marked by the refinement and intensification of industrial technology, led primarily by the United States and Germany. It was characterized by the integration of science and industry. International competition and imperialism surged during this period, with countries seeking to secure resources and markets. Core technologies: electricity, oil, assembly line. Electricity enhanced energy efficiency and enabled night shifts and urban life. Oil became a crucial fuel and a core raw material for the chemical industry. Assembly line: Henry Ford introduced the Ford system in car manufacturing, setting a precedent for mass production. Characteristics: mass production and industrial diversification. Rapid development in industries such as steel, chemicals, electricity, and automobiles. Emergence of monopoly capital as companies expanded. Standardization of technology, division of labor, and structured organizational management were implemented. Corporations established in-house research facilities, accelerating the industrial application of science. Socioeconomic impact. Expansion of global markets: mass production drove export-oriented industries and contributed to imperialist expansion. Enhanced division of labor. While productivity increased, workers became more alienated as their roles were reduced to mechanized processes. Completion of the modern industrial society. A mass consumption society, state-led economic policies, and modern education systems took root. Rise of labor movements and welfare systems. The growth of labor unions and socialist movements gradually led to labor rights protections and the introduction of social security systems. Third Industrial Revolution. Late 20th century. Historical background. Following World War II, technological innovation accelerated, particularly in the United States. The oil crisis and economic stagnation of the 1970s prompted the search for new ways to increase productivity and efficiency, leading to the advancement of information and communication technologies (ICT), core technologies: computers, ICT, automation, the spread of computers and the development of microprocessors dramatically improved information processing for businesses, governments, and individuals. The advent of the Internet revolutionized the distribution of information. Industrial automation enabled precision manufacturing. Using robotic systems in factories, characteristics, digital revolution, and information society. Society transitioned from analog to digital systems, with information becoming a key asset. Traditional industries like banking, education, and retail were digitized and moved online. Service industries grew in importance, surpassing manufacturing in many economies. Socioeconomic impact. Automation of manufacturing, human manual labor, was replaced by robots and automated systems, reshaping employment structures. Emergence of the information economy. Information became a primary value-generating resource, highlighting the role of knowledge workers. Global networking borders became more porous as business activities globalized, solidifying the dominance of multinational corporations and global capital. Digital divide. Differences in access to and use of information. Technology deepened social inequalities. Fourth Industrial Revolution. Early 21st century present. Historical background. Building upon the Third Industrial Revolution, the Fourth Industrial Revolution represents a fundamental qualitative shift. It is defined by hyperconnectivity, superintelligence, and technological convergence, wherein humans, machines, and data are all interconnected through cyber-physical systems (CPS). Core technologies. Artificial intelligence (AI) mimics human thinking and learning, applicable across industries, including healthcare, education, and finance. Internet of Things. IoT devices and sensors are connected to the Internet, enabling real-time data collection and analysis. Big data. Massive data sets enable predictive analysis, decision-making, and personalized services. Robotics. Advances in automation, smart manufacturing systems, and collaborative robots. Biotechnology. Merging of life sciences with technology to create new industries such as gene editing, personalized medicine, and bio-artificial organs. Characteristics. Fusion of physical, digital, and biological worlds. Emergence of digital twins and metaverse technologies, integrating real and virtual worlds. Convergence. Innovation. The boundaries between technologies are dissolving, fostering interdisciplinary innovation, hyper-connected society, real-time connection among people, devices, and systems. Super-intelligent society, AI-driven, decision-making complements or replaces human capabilities. Socioeconomic impact. Transformation of employment structures. Routine jobs are being automated, while new tech-based roles are emerging, reshaping the labor market. Creation of new industry sectors like smart manufacturing, healthcare, fintech, and smart cities are becoming key growth engines. Ethical and human rights issues. Questions of AI accountability, surveillance, and algorithmic bias are prompting debates on tech ethics and human-centered values. Sustainability and ESG expansion. Topics like carbon neutrality, green technologies, and corporate social responsibility are core themes of the Fourth Industrial Revolution. Importance of education and lifelong learning. Adapting to rapid technological change requires lifelong education, with creativity, critical thinking, and collaboration emerging as key competencies.